Hello, fellow programmers and mathematicians. This is another clip on the secant method. In my previous video on secant method, we look at a case of using the for loop in performing the number of iterations, and then we have realized that it works right, but we happen to have a couple of challenges when you want to perform a certain number of iterations. So then we want to now use another approach, which is the while loop in performing the iterations, and I believe it's going to resolve the problem that we encountered in the previous video. So let's dive into it. So first of all, we consider the number of the inputs values for the secant method, which we have A to be the first guess, the B to be second guess. Here we don't need a number of iteration again, so we quickly have to suppress that one or comment. We just have to comment it, or better still, we can still remove it from here. We can remove it from here, so we don't really need it. And then we need our function under consideration. So so from here we need our function. From here we also want to supply our tolerance. We'll be using tolerance under the while loop condition, and then we set a certain value, that's APS to that's 1 to the power 10. So from here, since we are not using the for loop, we now want to set our while loop, place our while loop condition, which we are saying our absolute value of EPS should be greater than our tolerance that we have set. So we then end it here. Let me leave a space here. So from here, then we are posing another condition that our EPS should be equal to the current value that we have solved for the secant under the secant method minus our previous B value should be assigned to our P. Then we went ahead to do a new assignment, which we say our old B value should be assigned to A, and our new P value should be assigned to B, and then we continue with the iteration again. So from here, since we are considering the for loop, the while loop, we don't need a for loop again, so we just have to ignore this one here. Then that is pretty simple. So now let's run it and see how it actually works. So we supply our initial guess. We have our function. Once again, we have it to be x, meaning telling us that we will be supplying that the function is going to take an argument. This x indicates that the function is going to take an argument of x values. So we have our x times x minus 1. We can suppress it. So a certain tolerance, we set the tolerance to 001. So then give us our roots, approximate roots that we are interested in. The approximate root that we are interested in. So that is so simple here. We can consider another case. We want to consider another case of which we have our, you can call the function, the script name. We have, let's say 0. We want to consider another function that's 1.5. Let's say 1.6. And our function under consideration, we have our to the power 3 minus 2 times our x minus 1. We close it. And we set another tolerance, maybe to any number. Let's say, okay, then give us our approximate root to be 1.618. So let's look at another case of which we set maybe the tolerance to be 0.001. Let's look at it. In that case, we have 1.5, maybe 1.7. With the same function, you just have to call the function again. And then we set our tolerance to 0.001. It gave us the same value. So this one has this brings us to the end of this clip. We have come to the end of this clip, and then we have seen that using the for while loop with a certain tolerance will help us to get the approximate root. Thank you. If this video happens to be of great help to you, please hit the like button and subscribe. Leave your comment down below. Thank you.